Hello dear students, today's our lecture is analytical chemistry, qualitative analysis, so introduction to the main analytical chemistry. Next slide please. Today we are going to talk about the general information about the analytical chemistry, analytical chemist's job, the sample preparation and interpreting the analysis. So what is analytical chemistry? Analytical chemistry is the science of chemical measurements. So here we are going to prepare the sample, making the chemical analysis in the laboratories and providing some methods and tools needed for the insight into our material world and with the answering of the 4 basic questions about the material sample. So first question is what? So what is the identity of the substance in the sample? The second one is where. Does the sample contain substance X? So from which substance it's content our analytical chemist sample. The second one is how much. So how much of substance X is in the sample. And the last one is what arrangement, structure or form is the sample was. Please. So analytical chemistry has the further classification and some different techniques. So first one is bioanalytical chemistry, material analysis, chemical analysis, environmental analysis, and the last one is forensics. In bioanalytical chemistry we are working like in the colloidal chemistry with the analytical systems, with the including also biology systems one. In the material analysis, we are working from the different types of the materials. The solid one, for example, the gels or the oils or another one. In the chemical analysis, we are making just chemical substance, just making some chromatography analysis or spectroscopy one. And they also, from the environmental analysis, we are making some research of the different types of the environmental one. And also we are having the different techniques, spectroscopy, mass spectrometry, spectrophotometry, chromatography, types them gas and liquid, and also electrophoresis, crystallography, microscopy and electrochemistry. The next. So areas of chemical analysis is the 2 main types of them. Is the qualitative analysis and the second one is quantitative analysis. Chemical analysis includes any aspect of the chemical characterization of a sample material, such as separation. So how can the species of interest be separated from the sample matrix for better quantitation and identification? So as you see from this picture, the man is eating very large amount of the dinner, and the second one is the answering just too small. So it means that this man is equals to the quantitative analysis, the number of them. The second one is equal for the qualitative analysis. So qualitative analysis is what, and the second one is how much. Okay, please. So what do chemical analysts do? Analysis is not just making the sample preparation, but also it applies noun measurement techniques to well-defined compositional or characterization questions. So research analytical chemists creates or investigates novel techniques or principles for chemical measurements, or conducts fundamental studies of chemical, physical phenomena underlying chemical measurements, or develops new measurement methods on existing principles to solve new analysis problems. For example, if you during the laboratory works, for example, chemical analysts have some problems, and according to the requirements, he has just known expertise of them, and he has to create or to develop new measurement to finding the right way of the analytical problems. Okay, next please. So the analytical chemist's job is the sampling, sample preparation, chemical analysis, calibration curves, and interpreting the results. So also students, you are also in the laboratory works, are going to work like a chemical analysis job. So sampling, procuring a representative sample. This is the case 1. For example, here we have some sampling. 10 centimeters for the 10 centimeters. The cube 1 patches chosen at random, for example, yes. So random heterogeneous materials we have 10 meters from this side and 20 meters from another side. So we have this one and we are going to the sample preparation, yes. So next please. In this case 2, procuring a representative sample. We have the 3 different types of the samples. It may be, for example, liquid, solid, and liquid one. 3 different types of the substance. Segregated heterogeneous material from this side is 10 meters and from another one is 20. So you can see that under the microscope, you can see that a substance has 66% of this mixture. This is most of them. The second one is B, 14%, and the third one, C, is equal to the 20%. Please, next one. So now we are going to talk about the project 1, so how to measure the caffeine content of a chocolate bar. So I hope that most of you students like the chocolate bar, me too. This one is dark chocolate, another one is milk chocolate. So we need pestle and a mortar, because when we are working with the chocolate, we have to grain it very well. Please, next. All we know, like a chemist, that chocolate has theobromine and the caffeine. So theobromine is working like a biochemical precursor of caffeine, and caffeine affects to our central nervous system stimulant. Why do you think that when we are eating the chocolate we are relaxing? Yes, because we have some dopamine hormones in our organism. That's why we need also, when we are working a lot, when we are working hard or studying hard, you have to need to eat some chocolate bars. Please, next. So step 1, sample preparation. We are taking the sample. First of all, we are finely ground the chocolate. This is, you can see from here, this is the finely ground chocolate. And also this is the solvent. We can take the solvent, different types of, it may be ether, petroleum ether, or another one. So in the second one we have to shake it very well, because the suspensions of solid is put in the solvent, and under microscope we can see that they have different types of these particles. And after we are going to the centrifuge our mixture. So here you can see that solid residue packed at the bottom of the tube, because the chocolate has very solid solvents. So here is supernatant liquid containing the solid fat, and here you can see that the decant liquid will be just vaporized, and we have the fatted residue of chocolate bar. Next slide please. Here you can see that suspension of chocolate residue in the boiling water here, before transferring it to the centrifuge tube, and after we have the suspension of solid in water and centrifuged and taking from the 0.45 micrometer filters. We are injecting it from here, and supernatant liquid containing dissolved analytes any tiny particles from this side like drops. And after we are having here filtered solution containing dissolved analytes for injection into chromatograph. So withdrawing with the supernatant liquid into syringe and filter it into fresh centrifuge tube. Please, next. So step 2 is performing analysis with liquid chromatography. Why we are working with liquid chromatography? Because we are adding to the chocolate bar our petroleum ether. If we have the gas medium dispersed system, we are using gas chromatography. So here we have the column of our chromatography. Here with injecting analyte solution, the chocolate bar with petroleum ether, and after the hydrocarbon molecule chemically bound to silicon oxide particles. Here it's working like a sun. And the chromatography column packed with some amount of silicon oxides, and ultraviolet lamp also works here This is a detector which is analyzing our solution from the chocolate bar, and this is the output to the computer. Computer shows us how much chocolate bar and how much theobromine or caffeine containing in our sample, and also some amount of going to the waste. Please, next. So principles of liquid chromatography is will shown here. The first column, second, third, and fourth. So solvent in goes to the first column, solvent out going. From the second one, this is the solution containing both analytes here. This is the caffeine and theobromine. And after, in the liquid chromatography, it's divided into two parts. The caffeine is in the up and theobromine is in the bottom sides. So here you can see that caffeine is also becoming from the medium side and theobromine is going just in the bottom. Please, next. So step 3 is preparing calibration curves. So as I show you in the previous slides, you can see that in the detector sides from the column, it's going just to the out to the computer. From the computer in the calibration curves is showing that ultraviolet absorbance at a wavelength of 254 nanometers. It shows us the time units from 0 to 10. That from the starting here 2.6, the caffeine number theobromine is working up. Yes, this one. And after it's going down from the 3.8, 3.9, something approximately this one. And the caffeine is just showing us 6.7, yes, approximately 7 minutes. Please, next. So here analyte concentration parts per million, and here the peak height centimeters from 0 to 20, from 0 to 100 analyte concentration. So here you can see that graphs shows us the unknown part of here from 15 to 76. Theobromine is equal this equation, caffeine from this from lower one. So here you can see that theobromine is much than caffeine. Please, next. Step 4 is analyzing the results. So we are making the sample, we are making the analyzing, and now we are going just to interpreting the results. So this one is actively as I shown in the previous slide, just from the starting from the second minutes, it's going up and down. After we are not taking this one, just we are going to the constantly waving our theobromine's number. Please, next. So here it's a table 1, analysis of dark and white chocolates, grams of analyte per 100 grams of chocolate. So analyzing theobromine and caffeine. So dark chocolate contains 0.39, where white chocolate has very low. Caffeine also is much better than in white chocolate. So from here we can just make some conclusion that eating dark chocolate is much better than eating milk chocolate. Please, next. So general steps in chemical analysis is an analysis involves several steps and operations which depend on particle problem, our expertise, the apparatus or equipment is available, and the analysis should be involved in every step. Please. So our lecture is going to the end, and now I'm going to give you the exercise 1 and the exercise 2 in the next slide. So you have to perform this one. This is like a homework for you, and exercise 3. And till the next week, you have to send it me by email. So thank you for your attention, and I'm wishing you good luck on your